Hi, I'm JP Norer. Thank you for joining my presentation about three options that we have as modern electronics engineers to make GPS suitable for low-power devices. This is meant to be an overview because the topic can get very deep and we have a limited time. So let's get to it. Okay, so GNSS is what people who have implemented GPS call GPS. It's just a broader term than GPS, but the idea is the same. Problem with GNSS today is that it takes a lot of energy to receive the location information. Yes, I know there are a lot of amazing things coming in the future, but for now, probably in the next decade, this is the reality that we have if we don't do any kind of system optimization. We want GNSS to be more in line with an energy profile of an LPWAN device. LPWAN stands for Low Power Wide Area Network. Some common LPWANs are LoRaWAN and Sigfox, but there are others as well. I think it's so important for the energy profile to be compatible with LPWAN because location trackers are emerging as one of the killer apps for LPWANs, and location tracking requires knowledge of location. So that's where GNSS comes in. Let's talk about what we can do to reduce the energy requirement of GNSS by 10 times or more. I'm going to assume that you can put together a board with GNSS receiver on it and make the basic electronic optimizations. There are many modules available, so even if you're not an RF expert, you can get most of the way there pretty quickly. In my opinion, the best two parts that are out there are the u-blox M10 or the Sony 5610. Now, the Sony 5610 is almost impossible to procure, though, and forget about the support. So it's a bit of a unicorn. Nonetheless, it is the best. What remains, though, is the hardest part. We need to dramatically reduce the amount of time the receiver spends searching for satellites. That's what we talk about when we're saying time to first fix. So that's the time between when you activate the receiver and when satellite information comes into it. There can be very short or very long, depending on your strategy. And fortunately, there are ways to improve this dramatically from the defaults. The first way to do this, and indeed the best way, is to reduce the time of first fix by using Ephemeris data together with your receiver. This is also the technique your cellular phone uses to get a map fix much faster, but we can do it on embedded devices also. I've shown an example table of Ephemeris data. I downloaded this table a few months ago, actually, from a u-blox server with my software called BirdMon. It stands for Bird Monitor, Satellite Monitor. It's on GitHub. Feel free to use it. You may notice also that the Ephemeris data looks compressible, and it is, but that is a big additional topic. Right now, we're just going to focus on regular Ephemeris data, which is about 1 to 2K in size per download. Anyway, this Ephemeris data makes searching for satellites much faster, and it also improves the sensitivity of the receiver by at least 10 dB, sometimes even 20 dB. That's a lot of dB. And with all that extra link budget, you can get a decent location indoors or in urban environments, or, if you're making a wearable with a suboptimal antenna. So Ephemeris data can make compact electronics for this viable as well. So it sort of gives you a double bonus. There is a big caveat, though, to Ephemeris data. Ephemeris data is, well, ephemeral. It is only usable for 4 hours and realistically more like 2 to 3 hours. After that, it becomes useless. So your device needs to download Ephemeris data somewhat regularly. Many LPWANs are upload only or have very limited downstream capabilities. and that can make Ephemeris broadcasting a challenge. On the plus side, you can just broadcast it on a side channel. There is nothing secretive about it. It's public information. So you don't really need to worry about strong security with it. Nonetheless, using Ephemeris data in an LPWAN requires planning for system and network architecture requirements, and that's not always possible. Which brings us to almanac data. From an application perspective, almanac data is just a worse version of Ephemeris data. Worse location performance, slightly slower time to first fix, etc. But it has one huge advantage. That is, there are almanac tables available quite long into the future. 180 days is relatively easy to achieve, and it's possible to predict almanac tables for years into the future. There's a lot of cutting-edge research on this topic, so dig deeper into that if you're interested. The end game here is that it's possible to dump a long future of almanac data onto a flash chip, put it into your device, and never worry about connecting to the Ephemeris data server for the lifetime of the device. It's not quite as good as Ephemeris data, as we said. Maybe instead of a 10x improvement in your time to first fix, it's more like a 6x improvement. However, some of the modern devices are getting better and better about aided starts using Ephemeris data, including the u-blox M10. So if you think this strategy is interesting to you, the u-blox M10 might be the best device for you. The final option that we're going to talk about today is to use a vendor's location stack. I'm referring to, in this particular example, to Semtech's LoRa Edge as an example because it's very new and because it has LPWAN features built in. But it's not the only one. There are other options like this for some of the cellular IoT systems. I know Nordic has an option. I know u-blox has an option. So they're more than just this particular option. But the idea here is that we have a vendor supplied stack, and we have the same limitations of the vendor supplied stack as we do with anything that comes from a vendor. That is, there's vendor lock-in. Sometimes that's okay, sometimes it's not. I've included a link to a video presentation that does a deep dive on a field trial of this particular chip. You can see that on the bottom right. Please check that out if you're interested in this. I'll talk a little bit about this product also that's called the LR1110. I am not... This is not an endorsement or an official endorsement. I have no involvement with Semtech, but it is a cool part and one you should check out if you're doing something like this. It is a multi-radio device, and it can sniff GNSS signals and Wi-Fi. It can also communicate on LoRa networks. Together with this chip, Semtech has also released a firmware and a cloud software stack that efficiently resolve locations in the cloud. If you dig into their documentation, you'll see that they use almanac data as part of their stack. But you don't have to worry about that. That's the beautiful part of that, is that they do a lot of that system and network architecture for you. Wrapping up, I've produced this summary matrix to show some of the trade-offs that we've discussed in the past several minutes. Ephemeris Data Assistance definitely has the best time to first fix, but where it loses is in time to market. There's a lot of engineering and system architecture cost here that doesn't exist for the other options. Also, it's not the most vendor agnostic because you do need to download the Ephemeris data from somewhere. Two options here are u-blox and Google. Both of them offer Ephemeris management servers. Personally, though, I do believe it is worth the effort to use Ephemeris data in your LP-WAN application if you can. I am somewhat biased because this is how I do it. But what you do get is the best performance, the best low power performance. Also, there's something that's not in this matrix, which is versatility towards the application. So there are certain applications where having a vendor supplied stack might work for you because the location information is almost always only available to the cloud. So if I'm trying to do something like geofencing, where I want my device to know roughly where it is without having to touch the internet, you have to check to see if you can do that with the vendor supplied stack. Often you can't. In any case, there are more and more solutions coming up for low power GNSS all the time. You should not assume that GNSS is too power hungry for your application, or even that you can't do GNSS on something like a coin cell, because the truth is you can if you optimize your architecture. I saved the About Me slide for the end. If you want to get in touch with me, I'm on most social platforms. On all of them, just look for JP Norair. I'm the only one. Thank you for listening, and now we can move on to the next stage.